So one of the so-called proofs of the flat earth is that we see too far. But I'm going to bring up the question, if we live on a flat earth, do we see far enough? And flat earthers will reply, well, things are just too small to see due to perspective. And there is truth to that. But how far away is that? So my question is, if the earth is flat, then why is the world record long distance photograph only 275 miles? I'm going to show that it should be a lot farther than that. Now, how this came about was a response to this challenge by Professor Dave. Show something over land far away. Now, I don't agree with Professor Dave that it has to be over land, but he did suggest 1,000 miles. And I know you're going to recognize this individual because he has the maturity of a child, but his reply exemplifies the flat earther's attitude that only they understand how perspective works.
So, Professor Dave, would you expect the angular resolution to be conforming to seeing things at 1,000 miles? How big would something have to be in angular size to see it at 1,000 miles on any shaped surface? You complete clown.
So Nathan, instead of thinking that an abusive ad hominem attack is any type of evidence, why didn't you show Professor Dave that you couldn't see Mount Everest from 1,000 miles? The mountain is 29,029 feet in elevation, or 5.5 miles. If you're an expert in how perspective works, you must have heard of this formula. The tangent of the angle equals the height divided by the distance. I mean, that would be quite simple for Everest, 5.5 miles divided by 1,000 miles. Of course, when you do the calculation, what do we get? 0.32 degrees in angular size. Now, if you think this answer is wrong, there are angular size calculators on the internet that are quite easy to use. All you need to do is plug in the distance, plug in the actual size, and click the calculate button. And when we round it out to 2 decimal points, we get the exact same answer, 0.32 degrees. So I'm going to use this graphic to show that this mountain would easily be seen from 1,000 miles. So what I have over here is a ruler that is in tenths of a degree, and I have Mount Everest scaled in at 0.32 degrees. And now all we need to do is add an object of known angular size. And that would be the sun, 0.53 degrees in angular size. So this is how big Mount Everest would appear to be compared to the sun at 1,000 miles. So Nathan, who is the clown? And what about 500 miles? Now Everest is half the distance, so it is twice the angular size at 0.64 degrees. How come we haven't seen this photograph? And of course, we could even see a mountain half the size of Everest, 14,500 feet, 0.32 degrees. Here is a mountain that is 1/4 the size of Mount Everest. Here is a mountain that is 1/8 the size of Everest, 3,625 feet. Any of these peaks would be visible from 500 miles. Where are these photographs? So again, if the Earth is flat, why is the world record long distance photograph only 275 miles? Now the mountain in question is Peak Gaspard, which is 12,687 feet, and the individual had to be on top of a 9,000-foot mountain in order to take this photograph. Well, this is the angular size of Peak Gaspard from 275 miles, 0.5 degrees in angular size. They could have taken this photograph from the shoreline. And here is Peak Gaspard from 500 miles. Now its angular size is 0.27 degrees, or half the angular size of the sun. Where is this photo? Well, one of the reasons flat earthers believe in a flat earth is because they really don't understand how perspective works. There's two ways we can measure an object. The first is the actual size, and this does not change with distance. It doesn't matter how far away this 1,200-foot building is, it is always going to be 1,200 feet in actual size. But what does change is the angular size, or how big that object appears to be. And what we also know is that there is a direct correlation between the actual size of the object and its distance. And we know how to calculate this, and we know how to measure this with a theodolite. So if this first building is 5 miles away and you had a theodolite, it would measure at 2.6 degrees. And if you do the calculation of dividing this height by the distance, it will come out to 2.6 degrees. We also know that when an object is twice the distance, it will appear to be half the size. So in this case, the building is 10 miles away. Now it is 1.3 degrees in angular size. And when an object is 4 times the distance, it will appear to be 1/4 the size. 3 times the distance, 1/3 the size. 5 times the distance, 1/5 the size. And we can use this information to analyze photographs. Now, I'm sure most everybody is familiar with this video. About 2 years ago, it was the talk of the town in the flat earth community. But I'm going to use this video to show not a single flat earther used the rules of perspective to prove that this photograph was possible on a flat earth. So let's take a look at the video real quick. So the setting sun brings the mountains into view, and this is Canigou right over here. Now this is the details from that video. They gave it in meters and kilometers down here, but Canigou is 9,136 feet in elevation, or 1.73 miles. It is 163 miles from Aluche, and the elevation there was just over 1,000 feet. And of course, what do flat earthers do? They go to the curve calculator, they plug in the miles, they plug in the elevation, and they come up with a geometric hidden, which is 10,242 feet. And they subtract this from the elevation of the mountain. And of course, Canigou should be 1,106 feet below the horizon, and that is their flat earth proof. But the question they never answered was, do we see all 9,136 feet of Canigou? Because if the earth is flat, we should see this. Now this video was instantly debunked by the Globe community. This is from Sly Sparking. So what he did is he got a close-up photograph of the mountain. And then he scaled that photograph to match what you see in the video. And of course it was easy to understand that most of that mountain was hidden by the horizon. Now I'm going to use a little bit different method by comparing what we see of Canigou in this video to the sun, because we know the angular size of the sun. So here I have a circle, and I've used the width of it to determine its actual size. And you can see that there is a gap on the bottom down here. And of course that is caused by looming, because as the sun gets towards the horizon, we often see this. And since light here is being refracted downward, the bottom of the sun appears a little bit higher. Now what I did is I copied this circle and I pasted it to this screenshot, aligning it to the width of the visible sun. And you can also see that the amount of looming has increased. But now I can add a ruler, again in tenths of a degree, and now we have something that we can measure Canigou by. And we can see that Canigou is about 0.13 degrees in angular size. Now we know that mountain is 9,136 feet, so what would its angular size be at 163 miles? Well, again, this is a very easy calculation, and the answer is 0.61 degrees. And that is way up here. So now I can add another scale ruler. This one is in thousands of feet. We know Canigou in actual height is 9,136 feet. So I scale this ruler to that elevation. And we can see that we actually only see about 1,950 feet of that mountain. So you got to ask the question, how is this a flat earth proof? But if the Earth was flat, Canigou should have appeared to be this big from that distance. That means that there's over 7,000 feet of this mountain that we don't see, but we should see if the Earth is flat. So let's compare this to the globe model. So with the geometric hidden, the top of Canigou would be 1,106 feet below the horizon. But this is only a difference of 3,056 feet of what we actually see. And this is less than half of the air on the flat Earth. So again, how could this possibly be a flat Earth proof? And the refracted hidden is 8,342 feet. And if we subtract this from the elevation of Canigou, that means that 794 feet of the mountain would be visible on the globe. And now we only have an air of 1,156 feet. And this is the comparison of both models, and the flat Earth is dead last. And this is the problem with flat Earth logic. All they will do is this one calculation right here, the globe geometric. And since it is not a perfect match, then they will claim that they have proven the flat Earth. But what you will never see a flat earther do is make any type of calculation to show that their model explains it better. And you can see the reason for that right down here. They understand that their model is a reification fallacy. The flat earth is a belief. And there will be a part 2, which will be a challenge to flat earthers. I have picked out some locations with mountains in the distance, and these will be photos that will beat the current world long distance photograph, and it will also prove a flat earth. But trust me, you will never see a single one of these photographs.